Now, what I want to do is I want to show you where the graph of cosine comes from and why it looks the way it does, because we've already looked at sine, and then after that we can put the two together and start working some problems. Now, what I've done here, I've not approached this exactly the same way. I've not put together PowerPoint where I'm actually taking the lengths. Remember when I talked about sine, I actually took the heights here and I animated them over and showed how that we can build a sine graph. Well, the problem with cosine, remember, is that cosine is defined to be the x values. So it's just a little more involved to do that same trick. However, I can still illustrate where we get the graph of cosine. Notice what I've done here. I've put a grid up over here, and this grid goes from 0 to 2 pi. And it's divided into pi over 6 increments. So here's 1 pi over 6, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Of course, that's 2 pi. And what I did was, notice I've got this blue line right here. That blue line is a length that I measured from the origin of this circle to this point right here. So what I did, I drew the blue line here like that. And then I simply took that line and I moved it, flipped it 90 degrees and put it right here. In other words, what this measure is the distance from the origin out to the circle, which is 1 unit, right? Then I did that same thing over here for pi over 6. And I took this thing and I moved it right over to here. You see? Everybody see what I'm doing? And then I did the same thing for pi over 3, and that is right here. And then, of course, at 90 degrees, cosine, the x value is 0. Everybody see what I did there? Now, I did that, on around here. But you'll notice what happens right here. At this one, the cosine is now negative, right? Because the x values are negative. So at that point, I crossed over below the axis. So here we have a negative x value. Here we have another negative x value. And here we have negative 1. And that would correspond to this one right here in the middle. Does everybody see? And then I started, and then I continued on, still negative. And I just simply took these lengths, made them vertical, and place them over here until I get to 3 pi over 2, which is this, and it's 0. Does everybody see that? Then cosine goes back to being positive. So I get these, and then finally 2 pi. And here you see we have a nice shell formed for cosine, just like we did for sine. So you can see how we can relate the unit circle to actually this graph of cosine. Now, if you graph cosine in a continuous way, not like this, I've just set up the shell here showing you where the graph comes from. If you graph it in a continuous way, it looks like this right here. Okay? Notice it starts up here at 1. When you have 0, angle 0, it starts at 1. It decreases down all the way to negative 1 at 3 pi over 2. No, at pi, right? Is that right? Pi. See? From the unit circle, pi. And then it continues up all the way until we get back to 2 pi. Okay? Any questions about that? Okay. Now, let's just take note of some things about cosine. First of all, the domain of cosine. The domain of cosine is all real numbers, just like sine. So the domain, we have negative infinity to positive infinity. That's the domain for cosine. Okay. Now, the amplitude that we're looking at here is the same. It's defined to be as the same as for sine. It's just the distance from the line about which the graph oscillates all the way to the top or to the bottom. That distance is the amplitude. So in this case, the amplitude would be, 1 on this basic graph. So let me. Okay. So that amplitude right there is 1. I'll just put it there where we can clearly see. And remember, amplitude is never going to be negative. Amplitude is always positive. It's half the distance. Another way to look at it, it's half the distance from the bottom of the graph to the top of the graph. Okay? Now, likewise, the period of this graph. If you want to talk about how long does it take just the basic cosine graph to make one complete cycle. What do you think the period is? Any idea about what the period is? 2 pi, that's right. Just like sine, because it takes one complete revolution around the circle for it to go through all the parts of its cycle. So the period is going to be 2 pi. So you see, it's very similar to the graph of sine. Very similar. Any questions about that? Yes, sir. Okay. Okay, now let's. You notice I've been pointing out these similarities with sine, and there's a good reason for that. I'm going to show you the graph of sine and cosine on the same axis here. Now notice, I've got 2 graphs here. And by the way, I've set this graph to go from negative 2 pi to positive 2 pi. Now notice this. These are very similar. Now, you can tell which one is which just because I'm telling you this is just, one is basic sine graph, no translations, and one's a basic cosine. So which one would you think is the cosine and which one's the sine? Okay, now look, this is the origin here. This is the xy axis. Which one is this? That's the sine because at 0, sine is 0, right? So remember, sine starts at 0, goes up, down, and back where it started. That's sine. We recognize sine, well, it starts at the origin. Now, if you look at cosine, the cosine of 0 is 1. So here, the blue, you can tell, is the cosine. And it goes up like this. But the point is, there's really not any difference in them except for where they start, right? Notice, think about this. Think about what would happen if I took this, I guess we're calling it gray, right? Kind of greenish gray. What if we took this one and pushed it over just a little bit? Wouldn't it just be right on top of this graph? Exactly. In other words, if you look at the graph of sine and cosine, they are going to behave exactly the same. They have the same period. And in fact, they are just shifts of each other. Notice we said, well, what if I scoot this over? It will be exactly on top of this graph, right? How much more do I need to scoot over? Well, look at this. This is 1 pi over 6, 2 pi over 6, 3 pi over 6. What if I take this graph right here, this blue one, and push it over? How far will I have to push it? In other words, I want this point right here to be on top of this one. How far do I have to push it? 1 pi over 6, 2 pi over 6, 3 pi over 6. What is 3 pi over 6? Pi over 2. Now that's significant because what we're saying is if I shift this graph right here, this blue one, pi over 2 units that way toward the right, I will have a graph that is a sine graph, right? In other words, I'm calling this cosine, but if I shift this cosine over a little bit, I'm going to have the same graph as sine, right? Now, think back at why that would be the case. On the last test, I said this. I said, suppose that angle A plus angle B equals 90 degrees. And I said, sine of A equals H. What does cosine B equal? H, that's right. Because sine and cosine are cofunctions. So, if you have two angles that add up to 90, then sine of one is going to equal to cosine of the other. Well, that's why this is the case. That's why if you look at this graph, if you look at these two graphs, you can get the other graph just by moving the other one pi over 2 units. So if I want to take this sine graph and make it look exactly like that cosine graph, all I have to do is move it to the left pi over 2 units. If I want the cosine graph to be exactly on top of that sine graph, I just move it to the right pi over 2 units. So you can see this is an important concept because later on we're going to be given applications. We're going to be given a scenario and say, well, maybe a scenario involving tides. We'll be given high tide and low tide, the time between tides, the period between tides, and we'll be asked, come up with a mathematical model involving sine or cosine for this tide, the tidal behavior. Well, we're going to find that it doesn't matter if you use sine or cosine. Sometimes one is easier than the other, but they're both the same. You can model things. Some things are just easier to model with cosine than they are with sine, but what you can model with sine, you can model with cosine because all you have to do is shift it a little bit. Any questions about that?